Today we'll be solving the question from Leetcode, today's daily problem, that is Leetcode 947. Most stones removed with same row or column. On a 2D plane, we place n stones at some integer coordinate points. Each coordinate point may have at most one stone. A stone can be removed if it shares either the same row or the same column as another stone that has not been removed. Given an array stones of length n where stones of I is equal to xi comma yi represents the location of the ith stone, return the largest possible number of stones that can be removed. Okay, so let's first understand the question. So this is the question and this is our example. Here, as you can see, the answer is 5. Now why it is 5? See, the 0 is related with this 0 comma 1. Okay, so let's do like this. This 1 comma 0 is related with 0 comma 0. Okay, so like this. Now, if you can observe one thing, if you first remove 0 comma 0, these two stones would not be removed. So during removing, you should take care that you remove proper in the proper order, right? Now this 1 comma 2 is related with this. Okay, so let's go like this. Now this 2 comma 1 is related with this one. This is also related, and this 2 comma 2 is related to both here, this and this. So if you can think, what is the optimal strategy, right? So in removing 2 comma 2 is a better option. So first we remove 2 comma 2, then we remove 2 comma 1, then we remove 1 comma 2, because removing 1 comma 0 doesn't make sense actually, because 1 comma 2 is already there, right? Also removing 0 comma 1, we may lose 2 comma 1. So let's first understand this question in another way. So here I have made, okay, so let's understand it in different way. Okay, see, 0 comma 0 is related with, see, this is 0 comma 0, this is related with 0 now this is first, so we left. Now this is 0 comma 1, this 0 comma 1 is related with 0 comma 0 with this. Okay, with this row are same, right? Now 1 comma 0 is also related with 0 comma 1, so we put it like this, right? Now 1 comma 2 is related with this 1 comma 0, so we also connect this 1 comma 0 with 1 comma 2, right? Now 2 comma 1 is related with what? This, right? This one, so we merge it 2 comma 1, right? Now 2 comma 2 can either be joined from 2 comma 1 and 1 comma 2. So let's join it with this 1 comma 2, 2 comma 2. See, this representation helps us to understand the question more better. This tells us that on removing 1 comma 0, we may lose the removal of these two stones, and removal of this may lose this stone and this, right? Removal of this stone, because if we remove this stone, we can't remove these two stones, right? So the optimal strategy is like remove this, then this, then this, then this, and this, right? No. So do we care? Do we really care for the order how we remove? We don't care. So the main thing here is that how many pairs are in one group, because its head, there will be one head who is like parent or the most up or most like head of that pairs, which would be removed last, right? So so this whole group is of 6 pairs, so 6 minus 1 pairs can be removed. So what is our main task? Our main task is to find these groups. So if we find these groups, we know one thing for sure, that let's say we have m groups, and let's say we have total n nodes, n pairs, okay, n pairs, and we have m groups, right? M groups, okay. So we know that this m, the m heads, the head of each group will be always be there, but all the other nodes will surely be removed by them. So our answer is n minus m. This is the main thing, which is our what first thing is to find all these groups. Now see, whenever this finding of groups things comes, one thing should be clicked to your mind is that we should be using a data structure, that is disjoint set union. The disjoint set union helps in doing some operations in groups and finding that, right? And when we find a number of groups, we just need to find this n minus m. Why n minus m? Because the m head of the all the m parent, the ultimate parent that we say in the language of the disjoint set union, they can't be removed, but all the other nodes or pairs can be removed. So because of this, our answer is n minus m. So what is our main task? Now our main task is to find, we know n, we know how many pairs are here. We have 6 pairs and we have one group, so our answer is 6 minus 1, that is 5. So we need to find this number m actually, right? How many different groups are there? So we will be using what? Simple. We will be using disjoint and union, right? So here is that, see, I have written our answer will be total number of nodes minus count of parents, right? Because of that, each parent we can delete all its group nodes, but the main parent can't be deleted or removed. Now, so what is our approach? See, we know that there is a disjoint union data structure. Now I am taking the help of map because each pair is represented by a node, right? Yes. Now what this row P and col P map are? See, they are telling that okay. So let's go to the example where we will get more information from this. Okay, so okay, so here if you see this, let's say, okay, so let's come to the an example. Okay, so this is, so let's say we mapped, or it's simple, 0, 0 is mapped with 0, right? 0, 1 is mapped with 1, 0. This is 2, this is 3, this is 4, and this is 5. So what my row P map says, that okay, you have let's say 0, 0. Okay. You have sorry, there is a mistake here. Okay, wait a minute. This is not pair. It is actually, it is int only. It is mapped int only. Okay. It is int only, normal int. Okay. See what the col P and row P tells. The col P and row P says that I have, let's say, 0 throw here. I have here. Okay. I have here 0 throw, right? I have here 0 throw. So till now, who is the main like head of 0 throw? Tell me that. That is what the row P is storing. Row P is telling, okay, what is the ultimate parent of 0? Tell me that. Tell me that. Okay, row P of 0. Initially, if I would be there, initially as it is marked, okay, sorry, as they are all marked 0. So see, row P of 0 is what? It is initially it's 0, ultimate parent. What is col P? 0. Col P, it is an also map. We are just mapping that who is the main head of 0th column till now. It is 0th node. This is storing the node and number, right? These are already mapped, okay, and this is storing it, right? Now see, when 0, 1 comes, what is our main task? We need to unite this node, this 0, 1 is represented by 1, and we have till now we have only 0. All are separated. 0 is separated, 1 is separated, 2 is separated, all are separated. But this 0, we need to connect this 0 with 1. But how we know that? We will know by this 0. So we will check, okay, the row P of this 0, is it already head? Does it have head? If it have a head, so unite this 1 and 0. Simple. So we unite this 0 and 1 by using this row P, because row P of 0 is what? 0. And this 2 should be united, right? Because they share same row. And similarly, col P of 1 is also initialized with what? See, now col P of 1, should it be initialized? Its head is 0 or 1? Its head will be what? Yes, its main head will be 0. It depends on algorithm, but we say we have made a DSU. Its main head is 0. So col P of 1 is also handled by what? 0, right? Now let's come to 1, 0. We are doing a dry run type of thing, right? Now 1, 0. What the 1, 0? So I am removing. Okay, so indexing helps. Okay, so now 1, 0. What it shares? It is in 1 row. It is, but still now, till now there is no one to unite. But 0, if you see this 0 and 0 matches. So col P of 0, which is 0, and this 2 gets united. Simple. Now, so see, col P of 0 is 0. Now what col P of row P of 1, what it will be? The row P of 1 will be what? It will be 0. Because now 2's parent is what? 0. Right? Because it was united by here. Then comes what? It comes 1, 2. Right? Now what is col P of 1? Sorry, row P of 1? 0. So again 3 and 0 gets united. And there is also one thing, that is col P of 2. We are just mapping all the like columns with their respective ultimate parent node. Okay, so col p of 2 is equal to what? 0 again. Now let's come to 2 comma 1. So 2 comma 1 is what? 2 is, there is no one, but col p of 1 is 0, so 4 again get united with 0, and we get another new thing, rho p of 2 is 0. Rho p of 2, we will see how we will be implementing in the code, we will see. Now comes 2 comma 2, same thing, rho p and col p gets united. They are saying you have been 0th node united with 5, and just we get united. Thus, and final thing will be like, we use set data structure. We traverse all the pairs and we check how many different parents are there. Thus, if we get different, the number of different ultimate parents is our n, and we just need to minus it. So I have explained the dry run, and here I have taken a small example that initially these are our nodes. Okay, these are our nodes. Initially we have 0 comma 0, right? Initially we have 0 comma 0, right? And this is just code type. This is a snippet of code that we are going to write. This two, okay. So initially the thing is that this 0 and 0, the col p rho p of 0 is 0, right? Then we find this 0, so 1 gets united with what? With what? This 0, because this 0 and 0 are same. Then again this 0 comma 3 same, so it gets united. Now understand it. The col p of 0, col p of 2, col p of 3 should be 0, right? Because its ultimate parent is 0. Then comes 3 comma 0. Again we see this col p of 0, so it is again united. And then this 3 and 3 are united, right? 4 and 5, okay? And thus our answer is what? 1, 2, 3, 4, 5, 6. 6 is n minus m, and m is 1. M is the different number of groups, right? This is the example which is saying there is only one parent, one node. Okay, so there's nothing to do. Here is also an example. If you could see here, 1 comma 1 is different, which is second node, and all other nodes are united. There are two groups. There are 5 nodes, and 5 minus 2, that is n minus n, right? So now let's get to the code part and let's solve the question. Okay, so here is my DSU data structure. You can find on GFG or any article. It is simple disjoint set union. This P is like size, parent, SI is for size. I'm uniting the nodes choosing size, right? Just normal, it's constructor. Just FP is like my find parent function. Unite is like union function. It's simple. You can find anywhere, any YouTube channel. It's easy to find a template. Make a habit of writing DSU by your own. It helps in many online assessments a lot, right? Because DSU is like very important topic. Okay, now let's go to the code. Okay, so first, like, we take the number of nodes or the number of pairs, right? Now the main thing is that we need a 2 map, right? The row P, and it is I. Okay, so these 2 maps are just seen it for this 0th row, who is my ultimate parent. It is initially 0, right? Now I am initializing, just creating an object of my DSU class, okay, which is having n nodes, right? Okay. Now what our main goal is to get the number of groups, right? So let's take a set initially, set S, okay? Right now, our main answer will be like, okay. M is S dot size. We will be implementing here just to make and our answer will be n minus m. Okay. Now our main part comes here. Okay. Doing the traversal of my. Okay. I less than. Now, see what my first thing is that. My first thing is that. What is my row? Row value R. R is my st of I of 0, and my column value is what? St of I of 1. Okay. Okay. Now, first thing I need to check if initially is there any ultimate parent or not, because if it's not there, it will take default 0 value. So I would just check if my row P dot find R is there or not. If it is not, if it is there, okay. If it is there, what I will do? My node value is what? It's I. I is my current node value. I would just take it. Node is cur node is what? Cur node, just to make clear, cur node is I, right? If I haven't find if there is an ultimate parent here, let's say it 0 comma 0 was already initialized. Now I came here and my 0, the 0 well here when I came 0 comma 1, my row p of 0 will be 0th node, right? So I need to unite this what the 0th pair and this first pair because they share same row. Why? Because they share same row. So let's unite them. Unite what? Row p of that r comma this node cur node value, right? Same for what? Same for what? Same for column also, right? Same for column also, that if I am having column same, right? Why? See here, see this example, this is 0. Okay, so let's go to this example I showed you. Okay. This example, second node is having the 0th node same here, both same. So we need to unite 0 and 2, and col p of 0 is what? 0 and 2. So this 2 and 0 should be united, right? So same thing, col p is united with col. Now see, you have done, but now you need to like assign the value of like current row p, right? Because initially when we started our 0 comma 0, they both are not there. So we need to assign the row p of current r, right? So row p of current r is what? Nothing, just ds dot its ultimate parent and so this ds dot fp. So the row p of r, what should be assigned it, right? So we have an already ultimate parent, right, of row p of r, but it might be case that it gets changed during union of this cur node and row p of r. See, it's that it's already it would be row p of r only because cur node is size of 1, but still also what we will do is that as we already have united the cur node to row p of r and cur node r, we will just do this thing, that whichever will be ultimate parent of my cur node, right, we will assign it to this r, right? Means the current node have value r and c, and as we have united the cur node with all the row p of r and col p of r, we will just find the parent of the cur node and we will assign that to row p of r and col p of r, right? So why it is happening? See, initially let's we start with 0 comma 0. The cur node, this both if blocks will not execute. So this the parent of the cur node is cur node only. So both will have a 0 value, right? Next we come to 0 comma 1, right? Now 0 comma 1, 0 we already have 0 node, right? But when we see col p of c, as we have already united the 0 and 1, the ultimate parent of cul node will be what? 0 only. So col p of c, we will be assigning it to the ultimate parent of cul node because we have already done union of that, right? And finally, what we do is that we loop through all the nodes and we just find the different parents of that nodes, right? I is node, okay, so don't get confused, okay? It is nothing but node and different parents. The total number of different parents will be the size of the set, right? So now let's run and check, is it working fine or not? Yes, it's working fine, and let's see if it gets accepted. Okay, so it's getting an error. Okay, so col p of c. Okay, so slide an error, and let's now check. Okay, so the little error, it is col p dot find c, and I think now it should be working. Okay, so if you have, it's getting accepted, and if you have any doubts, you can ask it in the comment section. Thank you.